Hi, and welcome to this course of how to create a metaverse using JavaScript. In this course, you will learn the basics, the fundamentals about how to work with 3D using JavaScript, mainly using the library Three.js, which is really popular and is well documented. Now, we are going to start creating a folder named Metaverse with JavaScript. But the step number one is install Visual Studio Code. If you don't know how to install it, you can just Google it because it's really easy to do. The step number two is open this folder with live server in this way. The step number three is create an index.html file. I will assume you know something about HTML5. If you don't, just go to internet and looking for the fundamentals of HTML. Once you know and get ready to work with HTML, here just press exclamation mark and then see the suggestion of the Visual Studio Code and press enter. This gives us a boilerplate that then you have to press tab twice, and here press metaverse with JavaScript course. And then you have to put two scripts that are going to include JavaScript files. If you don't know how to work with JavaScript, go to internet, study JavaScript, mainly ECMAScript 6 modules, and come back here again. Now we are going to incorporate our library using this tag, script tag. We are going to do JavaScript JS.3.js. And we are going to put here defer because it's kind of new and new stuff, you know, something interesting to use, defer. So when we incorporate this defer attribute in the tag, we don't have to place it in the last part of the body tag as we used to do long time ago. So doing that, we avoid do that. So the next step is incorporate another script, which is src.index.js, which is gonna be our entry point, the first JavaScript code that is going to be executed in our project. In this case, is kind of exercise project. But the really important step here is don't forget add the attribute type. This is the most important step of doing the HTML file, is type the attribute type is incorporate the attribute type. So type module. This tags, this attribute allows us use ECMAScript 6 syntax. So we can write export and imports. So we are going to save this file, and that's all. Bye now. The next step is install live server extension. which is this one, live server. I have already installed it, so I don't have to do it, but you have to, because in this way you build up a static web server, server, in order to see this HTML file as a website in our local server. So you can click with the secondary button over the index.html file and then click here in open with live server, and in some place in your computer you will see your website. How do we know this is our website? If you check this title here, you will know that is our website because we placed this title inside of our HTML file. The next step after this one, as you can see, we can go slowly but really clear. The next step is incorporate the Three.js library. There are a lot of documentation out there that teach you how to install the Three.js library using npm. That is not my way. I don't recommend do that if you are learning Three.js. The best way to install Three.js library in your project is the way I will teach you right now, right here. So you have to go to the official documentation, which is Three.js.org, and then click here in the very first link, which is documentation, and after that came to this link, click on this link, and then you will find the very update library of Three.js library that you can copy with Ctrl A, select all with Ctrl A, copy with Ctrl C, change the window using Alt Tab, and now holding Ctrl key and clicking on this first link, you can create this file automatically because of Visual Studio helps you. And now we can paste the code here, but it's going to do that Visual Studio complained with me. So I am going to open this file with Notepad because it's faster, it's light, very light. We're going to paste this code, we're going to save this file, I'm going to close this window, I'm going to back to our project, and hopefully the OBS, the application that I am using to record, is not complaining with us. So now we can see we have our library in our project. It is 36,000 lines of code. That is alright, doesn't matter the size, because we are learning, just learning. So now we have the Three.js library already installed. The next step is start with our hello world. In order to do that, we are going to back to the getting started, to tutorial in the official documentation, we are going to copy this style. If you don't know what is this style for, go to Google, try to learn CSS, and then come back here. With this line, we drop off the margin in the body, which is something uncomfortable when we are working with Canvas and Three.js here. As I told you before, we need to copy our Hello World project, which is all these lines here inside of this script tag. We are going to copy with Ctrl C, and we are going to create this file holding Ctrl key, pressing index, clicking, pressing the mouse button there, and now we are going to paste with Ctrl V. We are going to press Alt, Shift, and holding those keys, we're going to press F. Now the code automatically get beauty, and we are going to save with Ctrl S. We're going to save the HTML file again, and hopefully our project is showing the cube spinning. This is our Hello World, but there is something special step that we have to continue doing in order to improve our project. The main adding value I can provide you is telling you you don't have to do this code, you don't have to write this code in this way. I suggest to you improve your coding, refactoring this code in order to use modules ECMAScript 6 that will allow you copy and paste and reuse code easily. Let me show you how. To start, we are going to take off this line, and we are going to create a subfolder named basic. And inside of this subfolder, we are going to create the scene.js file, which is going to include this line we just copy. Cut. So, as I told you before, we are going to use ECMAScript 6 modules that allows us modularize our code, isolate it, and reuse it easily. To do that, we have to write export by default the scene in this case. So now we are exporting the scene object, and we are going to incorporate it here in this entry point file. As I told you before, this is the entry point file where we are going to execute our first running code. We are going to import that object. I used the Visual Studio Code features in order to make it easily. So what I made was come to here where is the object, put the cursor at the end of the object, and then press Ctrl and then the space key, and then I saw the suggestion and I click on it, or press enter. That was the case that automatically appear here, made automatically appear here this piece of code. And now we are going to do the same with the camera. We are going to drop off the camera. We are going to create a module, name it camera.js. We're going to paste the camera code. We're going to export by default the camera object. We're going to copy, we're going to save, we're going to close, we're going to close, we are going to Control F looking for the camera object. We're going to click at the end of the camera. We're going to press Control, we're going to press space key, and it looked like it doesn't recognize our module. So I'm going to try. This is not working as we expect. So the easy way is going to just keep at the first line, press Ctrl C, Ctrl V to duplicate the line, and now we can just copy camera, paste it here and here, start writing camera, press enter to accept the suggestion and add the JS extension. Now the camera is imported to this module because this index file is a module, ECMAScript 6 module. The camera is another ECMAScript 6 module, and the scene is another ECMAScript 6 module. It's kind of difficult to pronounce that ECMAScript 6 module. So we are going to see now how it is improving our code when we can reduce these 3 lines in only just 2. Cutting this piece of code, creating a new file named renderer.js, pressing enter. Now we paste it. Now we write export by default renderer, and now we can come to our entry point. Let me save this file. Control F, Control B. We place the cursor here at the end of the renderer. Hold Control, pressing space. Nothing happened. There is a technique I can share with you. You can press Control P, Control B, enter. Press Alt Tab. It's Control Tab in order to go back. And now press Control Space. And now after goes to the module and or the Visual Studio Code recognize there is a file named renderer, and now we can accept the suggestion just clicking here or pressing enter, and then automatically we replace the 3 lines I told you before by 1, not 2, only 1. So now we are reducing the line of code that we can see here in our entry point file. We will do the same with this piece of code related to the cube. We're going to cut it. Okay, not all of that, just the 3 lines. We are going to create inside of the basic folder another subfolder named shapes, and inside of that shape folder we are going to create our cube file that will contain our ECMAScript 6 module default cube. Now in our entry point we can just put the cursor at the end of the cube object, press Ctrl, press space, and now we can press enter accepting the suggestions, and automatically Visual Studio Code incorporate this import expression for us, and now we are reducing the code that we are refactoring. By the way, we are not testing our changes, but as you can see, this is still working. I'm so happy because I am teaching you, if you don't know, how to work with ECMAScript 6 modules in modern JavaScript way. So that makes me happy. The next step is replace this loop system with some system that allows us handle the loop and the callbacks inside the loop better way. So in order to do that, let me see. I'm going to open this project, which is my first try of this video, this recording. We are going to incorporate our loop machine, which is this ECMAScript 6 module. You can see here in this way. You just copy and paste, or pause the video and copy the code. And I'm going to copy this instance of this class. We are going to use it here. We are going to incorporate, pressing Control space, then enter, then dot, then add callback, then open the parentheses, then open again the parentheses, going ahead one step, then pressing equal, change equal, and then greater than, and then open the curly brackets, then copy these 3 lines inside of this callback, and then we are going to delete our old loop system, and now we are going to start this loop machine system with the method start. And if everything is okay, which is not, this have to, okay, this is still running, as you can see here. So this machine loop allows us incorporate many callbacks into the loop, and allows us also take off the callbacks from the loop to the loop. But this is another story. Now we're going to go ahead one step further, and we are going to talk about the magic numbers. The magic numbers are numbers that appear in our code and doesn't mean nothing for us, the developers, because there is no context. It's really hard to understand for us what represent those numbers. In order to avoid that, we can use enums, which is special objects used in other languages, but in JavaScript we can just use literal objects like this one. I will show you right now. This is an special literal object that allows us replace the number 8 by keycode.backspace, or allows us to replace the number 13 by keycode.enter. So in this way we can replace those magic numbers with something with more meaning. And this is useful for the step that we are going to do right now. Now we are going to cancel the rotation in the XY axis, and we are going to keep the rotation in the Y axis. So now the cube is spinning like a pizza inside of the microwave. We are going to move the camera position using a special syntax, which is this one, using set method. And now we are going to use the coordinate 5, 5, 5. Oh, let me show you something. 2, 2, and 2. And as you can see right now, the camera moves 2 meters to the right, 2 meters up, and 2 meters back. Because this is the XY, the X axis, the Y axis, and the Z axis. But we are watching a lost point on the horizon. But we don't want to do that. We want to keep watching the cube. So we are going to use the method lookAt. And we are going to place here the cube position, which is an object 3D. It's a 3D object, which is a special object that contains the 3 coordinates. As you can see now we are watching the cube, but from the right side, from the higher side, and the backer side, from the back. You know what I mean? But watching and pointing the camera to the coordinate 0, 0, 0, where is placed the cube. Now it's a good moment to talk about the 3D objects. If you know nothing about object-oriented programming, I suggest to you go to Google, learn some stuff about object-oriented programming, and then come back here. After that, we can go to the official documentation and go to the documentation, the very first link, and then click here in the search box and place object and write object 3D. And then you can click here and you will see this is the documentation about the object 3D, which is a special class that allows us create instance with methods and properties. And the interesting of this is that many objects in Three.js world extends from the object 3D. That is why many objects contain the method, let me check, method add, the method add. You already see here the scene has the method add, the method lookAt. Let me check this up. LookAt, Control F dot Control B lookAt. As you can see, we can place a vector 3D or the 3 coordinates X, Y, and Z. Let me show you. We can place here 0, 0, 0. And then make the test here. Oh, what happened here? Yeah, this is still working. What else? Yeah, we are talking about the object 3D. So many objects stem from object 3D and have the methods and properties that object 3D has. For example, the position, which is also a vector 3D. Alright, this is all the things I want to say or mention about the object 3D. And now is a good moment to talk about the vector 3D, which is explained here in the official documentation. If we click there, or that you can find if you write here in the search box vector 3. The vector 3 is a class that contains three properties and has method, for example, okay, it is not important right now. But yeah, as you can see, we can save information, the three coordinates information, inside of the object vector3. So now I assume you know, or you research about object-oriented programming, you know about Object 3D, you know about Vector 3, and now you can understand better. Yeah, this is the method I want to mention, the method set. If you're looking for pressing Ctrl F dot set, you can update the coordinate using the method set in order to update the three coordinates at once. You can also update the position in this way. Let me show you. X equals 2, Y equals 2, and Z equals 2. And now you can see this is still working in the same way. So in order to write 3 lines of code, it's better just make that magic, that update with 1 line of code. So now we are going to talk about how to interact, because at the moment we are just watching a cube spinning in the center of the screen. But now we can interact, and that is another key concept that we have to keep in mind when we are working, developing a video game, the interaction. So now we are going to incorporate in our project a special module named Key Listener, which is not included in the official documentation, but is created by me. Of course, it could be improved up, but I think it's working properly. So we are going to copy the instance which is export by default. By the way, if you want to export something not by default, you can export it using this syntax. For example, in this way, and in the loop machine also, you can export the class, this is the class, loop machine, as something that is exported not by default. You have to use this syntax. But this is something that we are not touching today. Yeah, I am going to incorporate here the key listener instance. I'm going to hold key control and then press space bar to see the suggestion. I'm going to press enter in order to incorporate, as you can see, the instance, not the capital object, but the instance, which is started with the non-capital, the lowercase. And this is the object that we are incorporating in our entry point file. Now I'm going to press the point, and the Visual Studio Code is showing us the suggestions. So we are going to use the isPress method. I'm going to open and close the parentheses, and now is the moment where we can use the numbers. We can write here number 13, but we don't know 13 what does 13 means. But if we press key code dot enter, now it's something more understandable for us. It's more comprehensive for the developer. Know that the value 13, it represents the enter key. So now, in order to, as you can see, there is a mistake here, because there is something wrong there. We need to wrap this expression, which allows us, which returns us a Boolean value inside of an if. So now, if we are pressing the enter key, the cube is going to rotate. But if we are not pressing the key, if the key is not pressed, the cube is going to be immutable. So now I'm going to press the enter key. Okay. Doesn't work. Why? Why it doesn't work? It doesn't work because the key listener is a system. And as I will teach you along this course and the future courses, all the systems have to be able to stop and start, because the optimization is a really important thing, signature stuff, really important thing that we have to keep in mind. Because if you put everything that you can, the computer gets tired and doesn't work properly. So that is why, if you have a chance to stop a system, to turn off a system, you are saving resources and make your game or your project works fluently. So that is why we have in many systems the method start and the method stop. And unfortunately, we have to start the system before to use if you want to use it. So now, if I press the enter key, we can see the cube spinning, and if we release the key, the cube stops. Great. I will teach you now some stuff about the lighting. I should talk about materials, but I will avoid that topic and I will touch that stuff in the future courses. But now we are going to talk about lighting. If you go to the cube, you will see we are using mesh basic material. The basic material is kind of fluorescence. Is like a neon, but we are going to use a standard material. Let me check material. Let me see the standard material. Here, this one. This is the one. We are going to go to here. We're going to duplicate the line. We're going to replace the material with the standard material, and we comment the first one, the original. Now, in our project, see nothing, because the material, let me go back. The basic material show the color without lighting. So we didn't incorporate the light into our project, but even like this, we saw the color green in our cube. Now we are using standard material, but the standard material needs a light. If there is no light, we can not see it. Like in the night when the lights are off. So now we need to incorporate a light module. And we are going to looking for in the official documentation light. The first light I will teach you is the ambient light. We are going to go to the documentation and click where ambient light is, and then we are going to copy the example and we are going to paste it inside of our module, and we are going to export by default light. And this line we are going to incorporate it inside of our entry point file. We're going to incorporate our light. Now, if everything is okay, we can see the cube again. The ambient light illuminate, provide light from everywhere to everywhere. So allows us to see the minimum coloration of the 3D objects, the meshes, the things, because object 3D is the class, meshes is a topic that we didn't talk about, and we can say the things that we watch on the screen. When we have ambient lights, we can see the coloration, the minimum coloration of everything. It's not the best light, but it provides us a minimum. Keep in mind that the minimum coloration of everything. Now we are going to incorporate an ambient light and we will see how different it works. So if we go to the library and now we looking for the directional light, clicking here and we see and click copy this one. Now we are going to reuse the module, the same module, and now we have the directional light inside of the ambient light module, but we are going to nest the directional light inside of the ambient light. By the way, yeah, so now if we go to the project, we can see the cube is lighting from the top, because the light is lighting from the top, lighting to the bottom. And this is why, because the original position, the default position of the directional light is 0, 1, 0, but not 0, 0, 0. By the way, if you go to the vector 3, documentation, you will see that the default value, where, let me see, the default value is 0, 0, 0, but exceptionally the directional light start with 0, 1, 0, which break this rule. This is an exception. That is the default position of the lighting, but the lighting is lighting to some target which is placed on 0, 0, 0. That is why we are lighting from the top. So if we now move the light position to different points in the x-axis, on the z-axis, we will see the difference. For example, if we change the position, which is a vector 3, and we can use the set method, and we place minus 10, 8, 5, we will see now the lighting came, the light came from other point, right? Now if we press enter, we can see how the shadows are in the cube. This is all the basic stuff I want to share you in these fundamentals, basic topics about Three.js and 3D development world. I hope you enjoy it and learn, and I hope see you in the future courses, in the following courses, because there is too many things that we have to still learning. Thank you so much. It was Federico Secaya. Bye.